Okay, so now we're going to look at review set 13A and 13B from page 370 on 71 and start with question 1. So the log of square root of 10 actually says what do I need to raise 10 to in order to get the square root of 10. So we can rewrite this as the log of 10 to the power of a half, and the log of 10 to the power of a half is a half. Similarly with this one, we can rewrite as, using our index law, 10 negative because it's on the bottom line here, and it's 1/3 because it's the cube root. So our answer is minus 1/3. For C, we use our index laws that say if we have the same base number multiplied, then we add the powers. So we have log of 10 to the A plus B plus 1. So our answer is A plus B plus 1. Okay, for the second part, we use our calculator. And basically, you just need to plug these numbers into your calculator. If you're not sure how to use your calculator to find the logs, make sure you see me immediately. And for most of these, we won't get a nice, easy number, so we need to round off a bit. So the log of 27 is around about 1.431. The log of 0.58 is around about minus 0.237. The log of 400 is approximately 2.602. And this part D, you don't really have to do this, but just so you know, this is the natural logarithm function, and you can just put that into your calculator. I think if you have the TI calculator, you'll see the ln button just below the log button, and the ln of 40 is approximately 3.689. Okay, now we're going to go to review set 13B and do, so these are a similar set of questions. So how do we write in form of 10 to the power of x, giving x correct to 4 decimal places? So in order to find that out, what we do is we find the log of 32 by putting it into our calculator, and that's approximately equal to 1.5051 rounded off. So therefore 32 is around about equal to 10 to the power of 1.5051. Same for 0.0013. We find out that the log of 0.0013 is around about minus 2.886. Now it's 8860, but the following number is 5, so we need to round up to 8861. Therefore, 0.0013 is approximately equal to 10 to the power minus 2.8861. Now 8.963 times 10 to the minus 5. We do the same thing. Now when you put this into your calculator, make sure that you are getting 8.963 multiplied. Then you put your 10 to the x key in and use your negative key and then the 5, and then do your right arrow key so that you can do your final bracket. So when you put that into your calculator, you get approximately minus 4.0475. So therefore 8.963 times 10 to the minus 5, approximately equal to 10 to the power of minus 4.0475. Okay, now going back to review set 13A, looking at question 5. We're using our log rules here. So the log of 16 plus 2 times the log of 3. We use, firstly, we'll leave as log 16 to start off with, and we'll simplify the second term here. So that's the equivalent of the log of 3 to the power of 2. So that's log 16 plus log of 9. And when we have, remember when we're added, we sort of go up the complexity. So that's the same as the log of 16 times 9, which is equal to the log of 144. Okay, now in part B, we're remembering that if they have the same base numbers, we treat them exactly the same. So the log base 2 of 16, so that's equal to, log base 2 of 3 squared equals log base 2 of 16 minus the log base 2 of 9. And that's equal to the log. Now the subtract here means we use divide. So 16 over 9. Now we could probably simplify that and put a decimal point in, but we don't really need to. That's fine as a result in that situation. Okay, with part C, we have to turn the 2 into a term where we have log base 4. So if our answer is 2, then that means the question was, what is the log base 4 of 4 to the power of 2? So this replaces that 2. So we can have both of our terms here written as log of base 4. Now, log base 4 squared is 16, plus log base 4 of 5. And we know from our log rules that we are going to multiply those two numbers together. So we have log base 4 of 16 times 5, which is the log base 4 of 80.